guys, so we're going to look at the Cessna 172, the major parts of this aircraft, and its control surfaces. So 172 is a standard training aircraft. This aircraft, if you take flight training, you'll probably fly in one form or another. It might be a Cessna 152, but the 172 has been around in one form or another since the early 60s. So let's go ahead and just deal with the major parts of this aircraft. Part number one we're going to take a look at is the nose of the aircraft. And the nose of the aircraft is going to contain our power plant. It's attached to our propeller for propulsion. The exhaust system is in the nose of the aircraft. So the nose of the aircraft in the Cessna contains our power plant for thrust. The next major portion of the aircraft is the cabin. In this case, the cabin has 4 seats. Not that you can always fill those 4 seats, because you always have to consider how much the aircraft weighs and what it can take airborne. And finally, the last part with the weirdest name, the part where the number is on the aircraft. We call that the tail number, by the way, the registration number. It's called the empennage. So the empennage of the aircraft is the back portion where the tail and vertical horizontal stabilizer are attached. And on some aircrafts, empennages are longer, shorter. Cabins are bigger, smaller. Think about a large jet aircraft. And some cases, the noses don't contain the engine. All right, let's take a look at our major flying features of this aircraft. So feature number one, I hope you notice, is the main wing of the aircraft. So the main wing of the aircraft is going to provide us the vast majority, although we do get a little tiny lift from the fuselage, nose, cabin, empennage, depending on how it's pointed into the oncoming air, but very, very little. Let's say 99% of our lift comes from our wing. So the wing is attached. In this case, you notice it's a high wing aircraft, so the weight hangs, major weight of the aircraft, including the cabin, hangs below. And I want you to take a look at this wing, and we take a look at a front view of this. And I don't know if it's as pronounced, if I can zoom in, but the wing has what we call a dihedral. Now, we talked about dihedral with your model aircraft you've built, but the dihedral is built in to give our aircraft stability. And this is a very slight dihedral, and the angle of the dihedral is going to be determined, in experimental test flights in a wind tunnel, and then actual experimental flights in the aircraft to find how it affects the overall performance of the aircraft and how it affects its stability. So let's move on to our tail section here and take a look at the horizontal stabilizer and the vertical stabilizer. So our horizontal stabilizer is what is going to give our plane horizontal stability, meaning in the up and down, and it's also in a horizontal configuration. Our vertical stabilizer is where we attach our rudder, and our vertical stabilizer is going to give us stability in left and right movements. So at this point, we're going to take a little further look at the wing, vertical stabilizer and horizontal stabilizer, and take a look at the actual control surfaces. So we've talked a little bit about control surfaces, and we've talked a little bit about the 3 types of motion an aircraft makes. And those motions are roll, and roll is along the longitudinal axis of the airplane, so along the fuselage. It rolls left and rolls right. One wing comes down, another wing comes up. We have pitch. Pitch is when the nose of the aircraft, or on our, I should say, not our vertical axis of the aircraft, we said longitudinal, we'll call that lateral axis. So the lateral axis of the aircraft pitches up and down. That is to, in most cases, depending on how the aircraft is pointed, it is either to climb or descend. And finally, we have our rudder and our vertical attached to the vertical stabilizer, which is going to give us stability and directional control in what's called yaw. So yaw is when the actual nose of the aircraft moves left to right. The wings stay level. It does not pitch up or pitch down, but the aircraft yaws left to right. So let's go ahead and take a look at each of these control surfaces, see how they work. So we're going to go ahead and move our ailerons here. So in a left turn, or a left bank, sorry, to roll the aircraft left, we are going to have an aileron on the left wing is going to come up, which if you just want to think about the air hitting that and forcing that wing down, and it will around the aircraft's center of gravity, which runs down the middle of the aircraft laterally, we will get a rolling motion or a descending left wing. And you can see the right wing, we are going to go ahead and put some lift into that wing, so that wing will come up, and we kind of put negative lift into the left wing, and that one will go down. Now as we bring this back to center, you can see the ailerons are smooth and level, streamlined with the rest of the wing. And as we roll the aircraft to the right, we get just the opposite movement in those ailerons. And what controls the aileron, now let's go ahead and take a look. We'll go ahead and go to the cockpit real quickly, and we will go ahead and attach the yoke. And better yet, we'll even scroll down so we can see the yoke. So there's our left and right roll using the yoke of the aircraft. All right, let's take a look at our next control surface here. Next control surface we'll take a look at is our elevator, and our elevator is attached to the horizontal stabilizer. And if you take a look inside the cockpit, you can see when we pull back on the yoke, we cause the elevator to move up, and when we push down on the yoke, it causes it to move down. So what will happen is the oncoming air will strike the elevator, the aircraft will rotate at its center of gravity, and the nose will pitch down. Or in this case, as we pull the elevator back, the airstream will hit the elevator, it'll move around its center of gravity and pitch the nose up. Notice these real small little areas, if you would. Let's see if I can scroll out here a bit. Okay, if you see these areas that are ahead of the pivot point, that's a little bit like, it has some weights in it, and it gives us a little bit of power control there. So we're going to let aerodynamics give us a little bit of help in moving that elevator, because in certain speeds, that elevator may be very hard to move in the aircraft. There's no additional control. This is basically your weight, your ability to pull on it, and mechanical advantage that's going to give us movement of the elevator. All right, let's take one look at one more control surface, and that control surface is the, I was going to say flaps, but not the flaps. It's going to be the vertical stabilizer, or rudder, or I'm sorry, attached to the vertical stabilizer. And there goes the truck, by the way. All right, so this is roll, this is pitch, and this is yaw. So again, we have the same sort of configuration here. We have a little bit of counterbalance at the top, and also providing us some aerodynamic help to move that rudder, as the wind will hit it on one side or the other. And the rudder, in this case, if we go inside the cockpit here, and we zoom in, I don't know if you can see that, but the rudder is controlled by the foot pedals. Okay, there's the foot pedals moving back and forth. And one other thing to notice is the foot pedals also control the nose wheel steering. So we don't steer this aircraft on the ground with the yoke. We literally can take our hands off of the yoke if there's no wind, and we steer the aircraft with our feet. When you first take flight training, that's kind of a weird feeling. Guys, that is all the different parts of the airplane that I'd like you to know for now, and it'll apply when we do our simulation. So if I'm referring to an empennage, a fuselage, remember the fuselage is the nose, cabin, and empennage. Wings, horizontal stabilizer, vertical stabilizer. We're all on the same page and we're all speaking the same language. All right, so next video we're going to take a look at is this actual airplane in flight, and we'll take a look at how those control surfaces move the aircraft.